When I say precious metals, most of you probably immediately think of gold and silver. Historically, they have indeed been precious metals. However, they're not the only ones. There are elemental metals that are rare and more expensive than gold. They have important industrial uses, and in some cases, they are much more expensive than gold. Learn more about platinum, palladium, and rhodium, the other precious metals, on this episode of Everything Everywhere Daily. This episode is sponsored by Stitch Fix. Gary, you're such a fashionable dresser. Said no one ever. I've always been, how shall I say this, a very simple dresser. However, I do acknowledge the need for having some clothes that make you look your best. And I also realize that I am probably not the best person to be making fashion choices. That is where Stitch Fix comes in. I set up an account on Stitch Fix. I gave them all my size information, and I also went through a series of onboarding questions to tell them what sort of clothes I like and what my budget is. For example, I'm not really big into floral prints or patterns. I'm more of a solid colors guy. Once they have the information, a real human fashion consultant will pick out clothes for you and send a box. My most recent box had 2 button-up shirts, a short-sleeve t-shirt, a light sweater, and a pair of pants. Everything looked great and cost far less than had I gone and purchased it myself. Make style easy. Get started today at stitchfix.com/everywhere. That's stitchfix.com/everywhere.
Hey, Kristen, how's it tracking?
With Carvana Value Tracker.
What else?
Oh, it's tracking. In fact, Value Surge Alert trucks up 2.5%. Vans down 1.7%.
Just as predicted.
Mm-hmm.
So, we gonna...
I don't know. Could sell, could hold.
The power to always know our car's worth.
Exhilarating, isn't it?
Tracking.
Always know your car's worth with Carvana Value Tracker.
I've previously done episodes on both gold and silver. Most of you are familiar with gold and silver, and there's a good chance that many of you own at least a little of it in the form of jewelry, coins, or silverware. Silver and gold are 2 of the 7 metals that were known in the ancient world, the others being iron, lead, copper, tin, and mercury. Gold and silver were the precious metals for thousands of years. However, starting in the 18th century, science began discovering a whole host of new elements, including new metals. In this episode, I'm going to focus on 3 metals: platinum, palladium, and rhodium. There are other metals that some might consider to be precious, including rhenium, osmium, and iridium. However, by the end of this episode, you will see why I've decided to focus on just these 3 elements. And I'm guessing that most of you have heard of platinum, some of you have heard of palladium, and most of you probably don't have a clue when it comes to rhodium. All 3 of these metals are in the platinum group of elements on the periodic table, along with ruthenium, osmium, and iridium. Before I get into what they have in common and their primary use, I'd like to go through the history of each metal. The first known use of platinum predates European awareness by centuries. Indigenous peoples in pre-Columbian South America, particularly in what is now Colombia and Ecuador, worked with platinum-like alloys as early as 600 BC. Archaeologists have uncovered jewelry and artifacts composed of a naturally occurring mix of platinum, gold, and other platinum group metals. However, due to platinum's high melting point and chemical inertness, these ancient artisans did not isolate it, but instead used native metal alloys found in alluvial river deposits. When Spanish conquistadors arrived in the Americas in the 16th century, they encountered these mysterious white metals in the rivers of New Granada, or modern-day Colombia. The Spanish called the metal platina, meaning little silver, viewing it as an impurity mixed with gold. They considered it a nuisance and even discarded it. Some records suggest that they tried to artificially transmute platinum into gold, unaware of its distinct properties. Platina is the root word of the word platinum. Despite this early encounter, platinum remained unappreciated and misunderstood in Europe for nearly 2 centuries. Platinum entered the scientific consciousness in the 18th century. Antonio de Ulloa, a Spanish naval officer and scientist, is often credited with introducing platinum to Europe. In 1735, during a scientific expedition to South America, he observed the metal and brought samples back to Spain. His report, published in 1748, drew the attention of chemists and mineralogists across Europe. In the mid-18th century, William Brownrigg and Charles Wood conducted early studies of platinum in England. They noted its high melting point and resistance to corrosion, key traits that hinted at its future usefulness. In France, chemist Pierre-François Charbonneau made significant progress in refining platinum by the 1780s. He was among the first to succeed in producing malleable platinum by painstakingly removing impurities such as iron, gold, and other platinum group metals, allowing it to be shaped and used for practical purposes. In 1803, English chemist William Hyde Wollaston discovered a more efficient method of purifying platinum via aqua regia, a mixture of nitric and hydrochloric acid and ammonium chloride. Platinum, along with other metals in the platinum group, as well as gold, are often called noble metals because they are very resistant to corrosion. Despite its scarcity, platinum gained traction in coinage and jewelry in the 19th and 20th centuries. In Russia, under the reign of Tsar Nicholas I, platinum rubles were minted between 1828 and 1845. These were the first major coins from platinum using Russian reserves from the Ural Mountains, where platinum had been discovered in the early 1800s. In the decorative arts, platinum's bright luster and resistance to tarnish made it a favorite amongst jewelers, especially in the Edwardian and Art Deco periods. Its strength allowed for intricate designs that securely held gemstones, making it highly desirable in high-end jewelry. Platinum is slightly more common in the Earth's crust than gold, having an abundance of 5 parts per billion. It has the symbol PT and atomic number 78. It's silver, dense, malleable, and non-corrosive. And as of the recording of this podcast, platinum has a spot price of $948 per ounce, although it has reached as high as $1,300 per ounce. Palladium was discovered in 1803 by the same William Hyde Wollaston, the guy who was credited with the discovery of the purification of platinum. Wollaston was working on refining platinum ore from South America using aqua regia to dissolve the platinum and then chemically separating the other elements from the solution. While experimenting, Wollaston identified a new metal with distinct properties. To confirm its novelty and avoid public skepticism, he first anonymously offered samples for sale in a London mineral shop under the name Palladium, after the recently discovered asteroid Pallas, which itself had been named after the Greek goddess Pallas Athena. Only later did Wollaston reveal himself as the discoverer. Although initially met with some controversy and disbelief because the scientific community was suspicious of anonymous claims, the uniqueness of palladium was eventually confirmed. Over time, it was accepted as a new element and added to the growing catalog of metallic elements essential to chemistry and mineralogy. In the 19th and 20th centuries, palladium was occasionally used in jewelry, often alloyed with gold to create white gold. Its brightness and tarnish resistance made it a preferred material for fine settings and wedding bands. It was used in coinage as well, primarily in commemorative or bullion coins issued by countries like Russia, Canada, and Sierra Leone. Palladium is more plentiful than platinum at 15 parts per billion in the Earth's crust. It has the chemical symbol PD and an atomic number of 46. Its properties are very similar to those of platinum. As of the recording of this episode, palladium has a spot price of $903 per ounce, and it had a peak once of $3,200 per ounce. Rhodium was discovered in 1803 by, you guessed it, William Hyde Wollaston, the year after he discovered palladium. He discovered it by analyzing the same samples of platinum ore imported from South America using the same techniques he used to discover palladium. After removing platinum and palladium from the solution, Wollaston noticed a rose-colored compound remaining in the residue. Through further analysis, he isolated a new, previously unknown element. He named it rhodium, derived from the Greek word rhodon, meaning rose, in reference to the pinkish color of its chloride salt, rhodium chloride. Rhodium's chemical symbol is Rh, and its atomic number is 45. It's extremely rare, estimated at only 0.7 parts per billion in the Earth's crust, rarer than either gold or platinum. Rhodium is one of the most reflective metals known, making it ideal for mirrors and coatings. Like the other platinum group metals, it's corrosion resistant, resisting attacks from most acids and atmospheric elements. And it's also not rose-colored as it's named in its base metal form. It's silvery. Rhodium is not mined directly. It's obtained almost exclusively as a byproduct of platinum and nickel mining, which limits its supply. As of the recording of this episode, rhodium has a spot price of $5,250 per ounce, making it one of the most expensive elements regularly used in industry, and it's reached prices as high as $27,000 an ounce. All three of these metals have similar properties. They're rare, silvery, and non-corrosive. However, they also share another attribute. They all have catalytic properties. They can accelerate chemical reactions without being consumed. In particular, all three of these rare and expensive metals are used in catalytic converters in automobiles. Catalytic converters are pollution control devices installed in vehicle exhaust systems that transform harmful emissions into less dangerous substances. These devices represent one of the most significant advances in automotive environmental technology since the 1970s. At its core, a catalytic converter functions through chemical reactions that occur when exhaust gases pass through its structure. These reactions don't happen spontaneously at exhaust temperatures, which is why catalysts are necessary. They enable these chemical transformations without being consumed. The primary reactions occurring within a catalytic converter include oxidation reactions, which add oxygen to molecules like carbon monoxide and unburned hydrocarbons, and reduction reactions, which can remove oxygen from nitrogen oxide compounds. Through oxidation, carbon monoxide becomes carbon dioxide, and hydrocarbons convert to carbon dioxide and water vapor. Through reduction, nitrogen oxides break down into separate nitrogen and oxygen molecules. A catalytic converter structure consists of several carefully engineered layers. At the center is the substrate or core, typically made from ceramic material formed into a honeycomb pattern. This design creates thousands of tiny channels through which exhaust gases can flow. The honeycomb structure maximizes the surface area within a compact space. When all the microscopic pores are considered, a modern catalytic converter can contain a surface area equivalent to several football fields. Some high-performance vehicles use metallic substrates instead, which offer better durability under extreme temperature conditions. The wash coat, a layer approximately 20 to 150 micrometers thick and composed primarily of aluminum oxide, covers this substrate. This wash coat serves multiple purposes. It increases the surface area even further, provides a stable surface for catalyst adhesion, and can include additional components that enhance catalytic activity. The rough, porous nature of the wash coat creates an environment where gas molecules and catalytic sites can interact effectively. The actual catalyst materials are embedded within this wash coat. Platinum is an excellent oxidation catalyst, facilitating the conversion of carbon monoxide and hydrocarbons into less harmful substances. Palladium performs similar functions to platinum and has become increasingly important as platinum prices have fluctuated. Rhodium specializes in the reduction side, helping to break down nitrogen oxides. These precious metals are used in extremely small quantities, typically just a few grams per converter, but their effect is profound. Temperatures also play a role in catalytic converter operation. These devices require heat to function properly, generally becoming effective above approximately 400 degrees or 204 degrees Celsius. When a car is just being started, before the converter reaches this temperature, emissions are significantly higher. This has led to various strategies in modern vehicles, including positioning converters closer to the engine, using electric heating elements, or incorporating specialized materials that become active at lower temperatures. Not surprisingly, catalytic converter theft has become a significant and growing problem worldwide due to the high value of the precious metals that they contain. These metals can fetch hundreds or even thousands of dollars per ounce on the black market, making catalytic converters attractive targets for thieves. These devices are relatively easy to remove from vehicles' undercarriages, often within minutes using basic tools. They also lack traceability, allowing stolen units to be quickly sold to unscrupulous scrap dealers. Hybrid vehicles, trucks, and SUVs are particularly vulnerable because they either contain higher qualities of these metals and or have elevated frames that make access to the catalytic converters easier. It is possible to buy platinum and palladium bullion in jewelry. Platinum is more common as a metal for these purposes, but both can be found. Rhodium, because of its scarcity and price, is much harder to find, but it is possible if for whatever reason you wanted to own some. Platinum, palladium, and rhodium are all rare, expensive, shiny, precious metals. However, that really isn't why they're important. It's their unique chemical properties that make the elements in such demand, as they are largely responsible for the reduction in harmful emissions from automobiles. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Austin Oakton and Cameron Kiefer. I want to thank everyone who supports the show over on Patreon. Your support helps make this podcast possible. I'd also like to thank all the members of the Everything Everywhere community who are active on the Facebook group and the Discord server. If you'd like to join in the discussion, there are links to both in the show notes. And as always, if you leave a review or send me a boostagram, you too can have it read on the show.